My name is Jakub Bochiński. I come from the Department of Physical Sciences, and the problem I'm trying to solve with my research is one that nags quite a large number of astronomers. The problem is, when we take astronomical data, when we collect astronomical data, a lot of it is being wasted and ends up in archives because of large systematic effects, which you can see in here. When we take astronomical images, we've hoped that they will look like that. Black background, some white stars on it. Unfortunately, quite often, because of the moon, because of clouds, because of other atmospheric features, we end up with these large background features that are very, very hard to remove. And because of that, lots of data that we collect ends up in archives, never properly analyzed. So what I was hoping to do with UltraCorrect, the algorithm I developed, was to actually try and correct for these mistakes, for these flows, remove them through modeling, and end up with pristine, clear images that we were hoping to get in the first place. And I developed it specifically because my project demanded that. We observed this planet orbiting around a star on 3 nights. On one night it was cloudy, on one night it was clear, on one night it was somewhere in between. And we ended up with this large feature there, which you can see in this picture. And initially we decided to just remove this data completely, not use it. But then I figured this would be a bit of a waste. It might be coming from the fact that I come from Poland. It was a slightly poorer country, let's say. We don't like to waste things. So we decided to make use of that and try to correct for it. And as you can see, it does a pretty good job in there. And building on that, what I was trying to do in here, I was trying to prove that there is something more in that system than just the planet orbiting around a star. And you can see our results in here, and they show that the model that assumes that there is just a planet in that system doesn't really fit very well with the data. And this is something we were searching for. We were hoping that the data would show something different than just a planet in that system. We're hoping that within this system there is not only a planet, but there is also a gas cloud, a condensed gas cloud, basically just in front of the planet. And this would, as seen from the Earth, the planet blocks part of the light coming from its star. With the additional cloud right in front of it, it should block slightly more light. So plotting brightness against time during the transit where the planet passes in front of its star, I would hope to see these points go slightly lower than they should because of additional absorption coming from the cloud itself. And this is what I can see in here and in there, in ultraviolet and in green filters. I don't see it in sodium filter, which is good. This is actually something we were expecting as well. So we were hoping to see that in some filters we would be able to see this cloud, in other filters we would not be able to see it at all. So potentially what I've done in here is we took some observations. One of them, one night, was spoiled by this systematic effect, and hopefully I managed to remove it completely now and retrieve all this data that otherwise would have been junked. Hopefully saving some observing time on these largest telescopes, and hopefully saving taxpayers some money, because observing on these telescopes is usually quite expensive. We have already applied this algorithm to data sets collected by our own Open University Pirate telescope. So we have a telescope that we can control remotely. It's on Mallorca. It collects quite a lot of data. Most of it spoiled by a large systematic inherent to the CCD, to the camera that it uses. And we've tried running this algorithm on one of these data sets, and it has corrected it, clearing out the systematic completely. So we know we can use it on archive data, trying to correct it. And I think there's quite a lot of archive data like that in the world that we can try and apply it to. We're already trying to think about a couple of other things we could work with, but I was told by my supervisor it's top secret and I can't tell anybody about it.